This golden chip looks simple, but its crisp texture begins inside one of the world's largest tree-borne tropical fruits. This heavy jackfruit holds moisture and sticky latex, yet the factory must turn it into a thin, golden crunch. How does a soft yellow slice lose enough water to snap cleanly without burning? The answer begins under reduced pressure. A mature jackfruit can exceed 20 kilograms, so padded receiving protects valuable edible bulbs before any cutting begins. During receiving conveyor, traceable lot separation prevents one receiving problem from becoming invisible later. Keep these on the far left, the rest go to the center lane.
Copy that. Moving them now.
Looks good, Supervisor. Flow is steady. Think of surface inspection like an airport baggage system, where every load needs a route and identity. Speed matters, but predictable handling matters more. Keep these moving along the line.
Right away.
Check the next batch for bruising. The raw materials are ready, send them through to washing. Roger that, Supervisor. A mature jackfruit can weigh more than 20 kilograms, which is why crews support it before cutting the stem. Support and controlled transfer reduce bruising before the edible flesh is exposed. This is why the line keeps the mature. Ensure the stem condition is perfect, use the sling support, and place them carefully in the padded crates. We need to padded crates. The clean fruit still has one major problem.
Most of its softness comes from water.
And the strangest removal step has not started yet. Keep them coming, checking for mold at the stem. This batch looks good, Foreman. Support and controlled transfer reduce bruising. This is why the line keeps the mature whole. Keep a steady rhythm on the sorting.
Right, Foreman.
That truck is ready to roll. Line it up here. Copy that. Release the crates slowly. Watch the slings. Think of unload to conveyor like moving a small suitcase that can bruise inside even when the outside still looks intact. Speed matters, but what can go wrong during receiving sort? Unsupported fruit can bruise or split before it reaches receiving. Every intact rind protects many edible bulbs, meaning a single damaged fruit can waste far more usable flesh than its exterior suggests. During lot control, support and controlled transfer reduce bruising before the edible flesh is exposed. This is why the line keeps the mature whole. The stem condition is excellent. Secure the slings tight and place them on the padded beds here.
Understood, Foreman.
The Act 2 reset closes this area with washed whole jackfruits still moving forward. The next doorway leads directly into wet preparation without reversing the slice thickness can vary by only a few millimeters, yet change moisture loss speed, making geometry part of the cooking process. The rind rinse detail is crucial. Consistent geometry ensures uniform heat transfer.
Checking moisture levels.
At wash line flow, the quality inspector watches bulb cleanliness, trim quality, and slice geometrying before. Think of drain after washing like cutting identical keys so every piece responds to the same lock of heat and moisture loss. Speed matters. What can go wrong during fruit opening? Uneven slices can dry at different rates and finish with different textures. This checkpoint exists before During bulb exposure, consistent geometry makes heat and moisture transfer more predictable from piece to piece. This is why the line keeps the cleaned. Rind, core, and seeds account for a large share of whole fruit mass, so edible yield becomes visible only after separation. At bulb inspection, the quality inspector watches bulb cleanliness, trim quality, and slice geometry before frying. A few millimeters of extra thickness can change how fast a slice loses moisture, so geometry becomes a quality control problem. What can go wrong during trimming? Uneven slices can dry at different rates and finish with different textures. This checkpoint exists before the material. Once bulbs are trimmed, every folded or torn piece becomes a future frying inconsistency, not merely a cosmetic defect inside the controlled production line. Consistent geometry ensures predictable heat and moisture transfer. This uniformity is why the line remains efficient. At slice grading, the quality inspector watches bulb cleanliness, trim quality, and slice geometry before frying. The Act 3 reset closes this area with pre-treated, drained jackfruit slices still moving forward. The next published jackfruit trials tested vacuum frying near 80, 90, and 100 degrees Celsius, showing how sensitive texture is to conditions. During drain detail, lower pressure changes water boiling behavior, while the sealed system controls heat and vapor removal. This is why the line keeps. Line 3 pressure reads nominal.
Baskets are clear on conveyor. Loading station 1 open.
Acknowledged. Proceed. We're focused on spreading them evenly now, ensuring the density is just right for the vacuum process. What can go wrong during vessel loading? Too much remaining water leaves softness. While during vacuum setup, lower pressure changes water boiling behavior, while the sealed system controls heat and vapor removal. This is why the line keeps. Pore formation is complete. We're stabilizing the vacuum.
Okay, moving baskets to de-oiling.
Progression. Think of frying progression like turning each slice into a tiny sponge that vents vapor through microscopic pathways. What can go wrong during vapor handling? Too much remaining water leaves softness, while excessive exposure can darken or as pressure falls, water can boil below its normal atmospheric boiling temperature, letting moisture escape before the fruit surface overheats as quickly. During crisp structure, lower pressure changes water boiling behavior, while the sealed system controls heat and vapor removal. I've stabilized the vacuum. Check the temperature on the gauge. Keep an eye on that flow. We're stabilizing the oil temperature now. Copy that. Products ready to move to de-oiling. Too much remaining water leaves softness, while excessive exposure can darken or overdry the slice. This checkpoint. During transformation payoff, lower pressure changes water boiling behavior while the sealed system controls heat and vapor removal. This is why the line keeps. This is the decisive moment. Reduced pressure lets water leave at a lower boiling point, creating crisp pores before the surface darkens too far. The Act 4 reset closes this area with vacuum-fried jackfruit slices still moving forward. The next door de-oiling is a separate operation because surface oil can remain after frying even when the internal structure already feels crisp. During centrifugal de-oiling, oil removal and cooling stabilize the porous fried structure before texture is judged. At surface oil check, the finished product supervisor watches surface oil, fracture behavior, and color after cooling. Think of de-oiling discharge like cooling thin glass after forming. Speed matters, but predictable handling matters.
Keep an eye on the consistency as they cool. Make sure they're not folding before the next station.
We're monitoring closely, ma'am. We see some folded ones near the tunnel. During texture stabilization, oil removal and cooling stabilize the porous fried structure before texture is judged. Cooling changes fracture behaviors after frying, so judging texture immediately at the fryer exit can give a misleading result. At primary visual grading, the finished product supervisor watches surface oil, fracture behavior, and color after. Think of fragment removal like cooling thin glass after forming, because structure keeps changing after the hottest moment. Speed matters. The chip snaps cleanly over the tray. The other workers continue sorting in the background. Broken fragments occupy real conveyor space at industrial scale, which is why grading continues even after the dramatic frying step has ended. During inspection flow, oil removal and cooling stabilize the porous fried structure before texture is judged. This is why the line keeps the cooled. At color check, the finished product supervisor watches surface oil, fracture behavior, and color after cooling. Think of a symmetrical post-fry line like cooling thin glass after forming. Structure keeps changing, but speed and predictable handling are key. What can go wrong during fracture texture? Residual oil or incomplete cooling can make two visually similar chips fracture. The Act 5 reset closes this area with cooled inspected jackfruit chips still moving forward. The next doorway leads directly. Even a small broken chip percentage becomes a visible pile over a long production run, making crumb separation economically meaningful. During light seasoning, screening and inspection protect intact pieces while fragments leave through a sex. At surface finish, the quality lead watches fragment shape, color consistency, and tactile crispness at the inspection. Complete pieces while removing distracting fragments. Speed matters, but predictable handling matters more. The machines move chips, but which ones feel right? The process shifts back to human judgment here. During paired inspection, screening and inspection protect intact pieces while fragments leave through a separate supported path. This is why human inspection remains useful because color, fracture, and shape can vary together in ways a single simple sensor does not summarize. The texture feels good. It fractured cleanly. Good color. The consistency seems right. Yes. Think of human quality judgment like editing a moving stream, keeping complete pieces while removing distracting fragments. Fragments can travel with intact chips unless the line removes them before final quality control. By the finishing stage, the factory is protecting texture rather than creating it, so rough handling can undo work completed minutes earlier. During crumb separation, detail, screening, and inspection protect intact pieces, while fragments leave through a separate color and fragment shapes look within spec. I'm noting a slight texture variation on the last batch. I need to get a closer look at this spot here. Think of supervisor correction like editing a moving stream, keeping complete pieces while removing distracting fragments. What can go wrong during final sample review? Fragments can travel with intact chips unless the line removes them before final quality control. The Act 6 reset closes this area, with cooled inspected jackfruit chips still moving forward. The next final quality checks track more than appearance. Moisture, texture, color, and oil content can all affect crispness inside the controlled production line. During texture QC, final checks protect the finished texture before the package becomes its moisture barrier. This is why the line keeps the cooled. The chips move from the metal detector, through the weighing section, and toward the carton stations. Think of filling like closing a weatherproof envelope around texture that earlier machines already created. Speed matters, but predictable handling matters more. What can go wrong during sealing and cartoning? A weak seal can allow moisture back into a porous, crisp product after the factory work. The Act 7 reset closes this area, with sealed packaged jackfruit chips still moving forward. A single production shift can move thousands of finished packages, turning one tropical harvest into snacks distributed far beyond the orchard. During factory departure, sealed handling preserves the factory result until an adult consumer finally opens and serves the product. This is why the line. The team stages the day's jackfruit chips by route to ensure consistent supply. They catch any variation before it goes to our partners. Think of retail receiving like handing off a relay baton, where every transfer must preserve what the previous stage achieved. Speed matters, but predictable. What can go wrong during shelf stocking? Rough distribution or an opened package can damage the same fragile structure. During shelf payoff, sealed handling preserves the factory result until an adult consumer finally opens and serves the product. This is why the line. Once sealed, the product may travel through several handling points before opening, so packaging protects the texture created inside the fryer. Think of home serving like handing off a relay baton, where every transfer must preserve what the previous stage achieved. Speed matters, but predictable. This is what we look for during final product macro. See the dry, porous surface and thin profile? Perfect. The final serving takes only seconds, but it depends on every earlier transfer keeping the chips dry, intact, and physically supported. The chip in this bowl is the same product from the opening frame. Now every hidden step behind that simple crunch has a place.